All right, so we're adding to our postulates, definitions, theorems notes, and what we're going to be looking at is some different theorems for the Pythagorean theorem and isosceles triangles, and then equilateral triangles. So the first one we're looking at is a Pythagorean theorem, and you guys have seen this before probably. And with the Pythagorean theorem, again, I wrote out these definitions, so if you want to hit pause, just hit pause and write it down, and then follow along with the explanation and the diagram and the example, okay? So it says, in a right triangle, the square of the length of the hypotenuse C is equal to the sum of the squares of the length of the legs A and B, okay? Well, all that says is, if I have a right triangle, and again, it has to be a right triangle, so we have to have that right triangle angle, 90 degrees, okay? The legs A and B and hypotenuse C, okay? So if A and B are the legs, and we have C the hypotenuse, okay? So if we have this guy here, where we have a right triangle where A and B are my legs and C is the hypotenuse, then A squared, this will always be true, A squared plus B squared, the two legs squared added together, will always equal C squared, okay? That will always be true. The two legs squared plus the added together will equal the hypotenuse squared, okay? Now, the converse of the Pythagorean theorem, the converse says, if C is the measure of the longest side of a triangle, A, and we have A and B are the lengths of the other two sides, and C squared equals A squared plus B squared, then the triangle is a right triangle, okay? So this is just flipping everything we just said. So this said, if we have a right triangle, then A squared plus B squared equals C squared. This is doing the opposite and saying, if I know that A squared plus B squared equals C squared, then I have a right triangle. So it's the exact opposite of what we just said. So if we have a triangle where A squared plus B squared equals C squared, then we have a right triangle. Okay, so it's kind of the same thing, but a little bit of opposite here, just in reverse order. So if we know that the two legs squared added together equals the C squared, then we have to have a right triangle, okay? Then the next thing I want to look at, there we go, is the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent, okay? So we know an isosceles triangle has two equal sides, right? Okay, two sides that have the same measure. So if I have a triangle here that's an isosceles triangle, let's say that this is A, there we go, B, and C. An isosceles triangle has two sides with the same length, right? Well, all this is saying is if A and B have the same length, so if segment AB, or we can even just say the measures, let's say the measures, if AB equals AC, okay, then the base angles, these base angles opposite those sides, so opposite those sides, also have the same measure. In other words, angle B, the measure of angle B is going to equal the measure of angle C, okay? And then if we know that the measures are the same, we know that those two angles are congruent, okay? So if two sides of the triangle are congruent, we know that they have the same measures, then the angles opposite those sides are congruent. So if these guys are congruent, and again, I said the measures here, but we know we could also say that these guys are congruent, okay? So if those guys are congruent, and then their base angles opposite those sides have the same measure and are congruent, okay? Then the converse is just the flip of that. It says if the base angles are congruent, then the sides are congruent, okay? So if two angles of a triangle are congruent, then the sides opposite those angles are congruent, okay? So similar situation here, again, going back to our ABC. It's just the same thing in reverse or order. This says if I know that these two angles are congruent, so angle B is congruent to angle C. If I know that those guys are congruent and they have the same measures, then their sides would also be congruent or have the same measures. So AB would be congruent to segment AC. In other words, those guys will have the same measures, okay? So if we know that the base angles are the same, then the sides opposite would be congruent and have the same measures. Okay. Last thing here, a triangle is equilateral if and only if it's equally angular. Okay, when you hear the word if and only if, that means it works both ways. So if it's equiangular, it's equilateral. If it's equilateral, it's equiangular. Now remember, we're talking about equal, so we're saying equal sides and equal angles. So if I have all three angles are the same, let's look at this guy. If we say that all three, well, let's label this first. Okay, let's say this is A, B, and C. Okay, if all three angles are the same, okay, so the measure of angle A equals the measure of angle B, and which is equal to the measure of angle C, that'd be equiangular, then all the sides also would be the same. Okay, so these guys would all have the same length. So AB would equal the measure of AC, which would equal the measure of BC. Okay, so a triangle is equilateral if and only if it's equiangular. So if all the angles are the same, then all the sides will be the same. If all the sides are the same, then all the angles would be the same. Okay?